Okay, solving. Graphing systems of equations. Example 1. Graph each system of equations. Y equals 4 and y equals 2x. The first line, y equals 4, is a horizontal line. So you should go up to 4 on the y-axis and then draw a horizontal line. The second line, you should recognize this from direct variation. This is y equals kx, or y equals mx plus b. If you notice, there's no number after the x, so the b is 0. So put a dot at 0. Now the slope is in front of the x. That's going to be 2 over 1. So from 0, go up 2 over 1, and then put a dot. And then you can go up and over again and put a second dot. Then connect them. These two lines intersect. The point of intersection is the solution, which is 2, 4. Okay, pause here, or example number 2. In example number 2, we have x plus y equals 2, and y equals 4x minus 3. If you notice, the first equation is in standard form. So we can solve for the two intercepts. First, we'll cover up the y and get the x-intercept of 2. Now we'll move over and cover up the x. This will give us the y-intercept of 2. So I'm going to come over here to x, put a 2, put a dot at 2, go over to y, put a dot at 2, and then connect. Now for the second equation, y equals 4x minus 3. This is y equals mx plus b. So we're going to start at -3, which is the b, and then use the slope, which is 4 over 1, and go up 4 over 1. Connect these two. You notice that we have two intersecting lines. They intersect at the point 1, 1, and that's the solution. Pause before we go on to the third one. Example here on the next slide. These are the three things that can happen when you have a systems of equation. You've already seen the first one, which is two lines that intersect. When two lines intersect, you have one solution, and you have a system that is consistent and independent. Now, the second option would be to have two lines that are parallel. Parallel lines have no solution and are inconsistent as a system. Our third option is you actually have the same line, where you have one line drawn over top of another. This type of system has infinitely many solutions, and the system is consistent but dependent. So these are the three options that we have when graphing systems of equations. We will have one solution with the point at the intersection. We will have no solution if the lines are parallel. And we will have infinitely many solutions if the lines are the same. Next slide. At this point, you should pause here if you'd like to solve this problem on your own before I start to solve it and show you for you. All right, the first one, x equals 2. This is a vertical line, so go to x equals 2. Draw a vertical line. That's different from the y equals in the previous slide, which was a horizontal line. Second equation, you notice this is in standard. This is not y equals mx plus b. So what I can do is move the 2x to the other side by subtracting. And the resulting equation will be y equals negative 2x plus 1. So 1 is your b, so that's where you want to start on the y-axis. The negative 2 is your slope, so make it a fraction over 1. That's your slope, m. So from the green dot, go down 2 over 1, put another dot, then go down 2 again over 1, then connect your points. You can see once again that these two lines intersect, and where they intersect is your solution. In this problem, that's 2, negative 3. All right, pause here before we go on to D. Next one. Okay, so you should pause here if you'd like to try D on your own before I explain it. All right, D. Y equals mx plus b. Notice there's no b at the end, so that's 0. So we might as well put a point at 0. The slope is 1/2 the number in front of x, so go up 1 over 2. Put a dot. Up 1 over 2, make a third one. Connect all of these so that you have a nice accurate line. Now when we go on to the second one, you'll notice this one is in standard form. So I'm going to go ahead and graph it in standard. So the first thing I'm going to do is cover up the y to get the x-intercept, which is 3. I'm going to slide my little blob over. He covers up the x. Now I can tell that the y-intercept is also 3. Okay, so I should put a dot at 3 on the x, a dot at 3 on the y, and then connect those two. You can see once again we have intersecting lines. This time they intersect at the point 2, 1. Go ahead and pause here before we move on to the next one. E. Pause here to try to attempt to do this one on your own. All right, if you notice, the first one here is in standard, so I can graph this in standard form to find the two intercepts. Covering up the y first, I get 2x equals 6. So if I divide by 2, I will discover that the x-intercept equals 3. Now if I slide that over, cover up the x, I see that y equals 6. So the y-intercept equals 6. So I'll put a dot at 1, 2, 3 on the x-axis. And for the y-intercept, I'll go up 6. 1, 2, 3, 4, 5, 6. I'll have to estimate there. And then I will connect these two. Now for the second equation, this one is also in standard form. So first up, I discovered that 2x equals negative 2. Divide by 2, I'll get an x-intercept of negative 1. Now if I move my little blob over, I'll discover that negative y equals 2. So if I divide by negative 1 to cancel out the negative sign, I'll get a y-intercept that's equal to negative 2. So go to negative 2 on the y-axis. Go to, oh, no, that's positive 2. So go to positive 2 on the y-axis. Go to negative 1 on the x-axis. Connect these two. You can see you have once again two intersecting lines, and this time they intersect at 1, 4. Okay, pause here before we go on to the next one. Okay, F. If you'd like to try these, pause. All right, with the first one, again, we're in standard form. So I'm going to cover up my y. So divide by 3, and I'll find out the x-intercept is 2. Slide my little blob over. This time I'll divide by 2, because that's the number in front of the y, and I'll find my y-intercept equals 3. So I'll put a dot at 2 on the x, 3 on the y, and connect. Now for the other equation, if I come over here and cover up the x, I divide by 3, I get a decimal. Now, graphing a decimal may be difficult. So instead of doing it this way, I'm going to go ahead and change the equation into slope-intercept form. So to do that, I need to make this y equals. So first up, the 3x will go to the other side, and I'll get 2y equals negative 3x minus 4. I'll get rid of that 2 by dividing. And my equation will be y equals negative 3 over 2x minus 2, because 4 divided by 2 is 2. So I'll graph this with my b, my y-intercept being negative 2, and my slope, which is m, is negative 3 over 2. Now if I go down 3 and over 2, I'm going to be off my graph. So instead, I'm going to take the negative sign and move it to the bottom. That way I could go up 3 and back 2. And I'm still on my coordinate plane. And you notice if you graph this, these two lines do not intersect. So this system of equation has no solution. All right, I hope this was helpful.